Welcome to the second lecture of our C++ from Python series. First, I wanted to review the homework. You didn't really have to get all the questions right. I was asking you to take educated guesses before we even learned what these things are in C++. But just to go over it, the \n is a new line character. When we put that in a string, we're signaling to C++, much like in Python, that we'd like to start a new line at this point, akin to pressing the Enter key, but we're not allowed to do that within quotes, so we use \n as a marker. Other special characters may also start with a \n. For example, if we want to put a quotation mark in the string. Int main is actually a function definition. The empty parentheses signify that the function named main takes no arguments, and the int that comes before it denotes the return type. Now, main is a little special, and we'll talk about that later. Also, you may have noticed that as soon as you created a second C++ file, the run button no longer works. That's good to me because I'd like you to have to compile by hand for now. I'd like you to type in these commands. The clang++ command, I know it's a little tedious. I don't want you to have to do it forever. But just remembering that there are actually two steps here when we run a C++ program. First, we have to compile it. We're asking another program, that's clang++, to read our source code and produce a program. Actually, running the program is the second step. When you do get sick of this, you can Google for configuring the run button on Replit, and they'll give you instructions. You can basically put whatever commands you like into a configuration file, and Replit will do those when you press run. I'm not going to go over a precise grammar for C++. Instead, we're going to start with some Python, and we're going to translate it piece by piece to C++. In this example, inc square or increment square takes a number, adds 1, squares that new number, and returns it. This is Python code that you can hopefully already read. There is an option in Python to include type information. This isn't really anything more than a comment by default. There are tools in Python that will double check this for you. But these annotations that we've added just say, look, I expect this function to receive an integer. I expect this function to return an integer. And this intermediate variable I am declaring as an integer. The reason I'm showing that is because those annotations in C++ are required. Let's look at the same function. The return type goes out front. The type of the argument comes before the argument. Now this is interesting. In Python, we denote block structure with indentation. In order to show that these lines are within the function, we indent them. In C++, blank spaces don't matter. You can indent however you like. Instead, we mark the beginning and an end of a block with curly braces. Next, when we increment x, you see that the line is mostly the same, except every statement in C++ ends with a semicolon. This also means that we can insert new lines in the code if we want to break up a long line. In Python, you have to do a little extra if you want to break a long line. We also see that we have a different way of marking a comment. It's otherwise the same. The # in Python marks a comment until end of line. A double / in C++ does the same. Similarly, we are denoting the return type before the variable. The variable type before the variable We have a semicolon at the end, we have a semicolon at the end of return, and when the block is done, when we're done with the function definition, we close the curly brace. Otherwise, this looks very similar to Python. So to go over, we're grouping with curly braces instead of indentation. We end every statement with a semicolon. Every function, every variable, every parameter has to have a type. We denote comments slightly differently. And I'll also say that a lot of flow control statements work pretty similarly, except the parentheses in them are mandatory. We'll see that later. And for better or for worse, one of these bullet points is going to take a lot more attention than the other four. And that's the types. This is going to make some parts of your programming harder. You're going to have to think through what types you need ahead of time, but it's also going to make some types of debugging easier. Fixed-sized integers. In Python, the integer type, int, can store arbitrarily large numbers. You can store integers that have 1,000,000 digits and still do addition and subtraction and multiplication. Now in C++, however, all of the built-in integer types have a fixed range. This makes your code faster. The reason is your computer actually has physical hardware that can do arithmetic, but only on these fixed size integer types. And as long as you stick to those fixed size types, your computer can do operations like addition something like 1 billion times a second. If, however, you want to do larger integers that have 100 digits, 1,000 digits, it has to effectively, instead of use that one little piece of hardware by itself, it has to run a simple program that says, okay, if the number's small enough, go ahead and just add it as normal, use the built-in hardware. Otherwise, it runs a program that does the same thing you learned when you first learned multi-digit addition. It first adds the smallest parts together. It takes the carry, it adds that to the next smallest part, adding those together, and it kind of walks step by step producing the output. All of that extra work and double checking makes arithmetic slower. If you do nothing but add numbers together in Python, it is much slower than it is in C++, and this is part of the reason. Let's look at what these types actually are in C++. They are typically the most common are int, short, and long, which are respectively usually 32-bit for int, 16-bit for short, and 64-bit for long. A 32-bit value can store anywhere from about -2 billion to +2 billion. Those correspond exactly to these values relative to powers of 2. And according to C++, if you ever go too high or too low, if I take 2,147,483,647 and I add 1 to it, C++ says your program might crash. In practice, you may see a different outcome, and I'll mention in a second what that might be. But formally speaking, C++ can crash if you ever do this. This is called overflow if you go too high, and underflow if you go too low. There are also unsigned types. These are unsigned int, unsigned short, and so on. They're the same size in terms of the number of bits, but they disallow negative numbers. What you get in return is, for a 32-bit number, you can go from 0 all the way up to 4 billion. And there's one additional difference, which is if you do wrap around, if you overflow or underflow, it just loops back around. If I take this number, 4 billion and change, the largest 32-bit unsigned integer, and I add 1, it always gives me 0. It wraps back around. And you can think of it as like a clock where the 12 position is a 0. And adding just means advance the hand forward by that distance. More formally, this is modular arithmetic. Let's go over some other types. A lot of Python types do have a perfect or an almost perfect fit in C++. In some cases, they don't quite match up. Anytime there's something that I think is at least philosophically a perfect fit, I've put it in bold. Both languages have a bool type. The biggest difference is in C++, the words true and false are all lowercase. As I mentioned, the Python integer type has a lot of counterparts in C++, each one with a different fixed range. But by default, C++ has no type that actually gives you however much precision you need. Slightly confusing, the float type in Python corresponds to the type double in C++. This is just historical. There are 2 types of floating point numbers that are typically supported in hardware. One is called single precision floating point. The other is called double precision floating point. C++ uses the word float for single precision and double for double precision. These days, it's rare to use single precision float unless you have particular constraints. So Python, to make it simpler, just uses the word float to refer to double precision float. Python has the built-in string type. In C++, there is a string type that is part of what's called the standard library, which I'll mention a little more about in a moment. You can also sometimes see work on strings done with a type that appears as char star. That's not really C++ so much as C, but because you can write C for the most part in C++, we also see that sometimes. I'll try to avoid it. The list type in Python has a corresponding standard library type in C++, std vector. I won't describe what this angle bracket T really means until later, but I will say that there is an important difference. In Python, if I have a list, I can add an integer to that list, and then I can add a string to that same list, and then a bool. I can add different kinds, different types of data to the same list. In C++, if I have a vector, every element of the vector must have the same type. Python's dict type also has an analog in C++, std unordered map. And finally, none type, which you probably don't see explicitly very often. But if you have a function that does not return a value, we also say that it returns none, which is of none type. It's a little bit pedantic, but it's there. In C++, if you have a function that you want to return nothing, you say it returns void. I haven't bolded the word void here because void has a few meanings in C++, and only one of those meanings corresponds to none type. Include. In C++, the include directive, that is the word include preceded by the pound sign, is similar to Python's import. It's not perfectly the same, but it's very close. Do keep in mind that that pound sign is important. It is not a comment. And these are some of the example libraries you will include most often. IOStream is where we get our standard input and output functionality. String for the string type. Vector for the vector type, which is the analog of list. Unordered map and set correspond to dict and set. Oops. And these are all part of the C++ standard library, so anywhere you can compile C++, they're already installed and available. Variables, mostly the same as what you're used to in Python, with the addition of we must name the type of the variable, we must end the statement in a semicolon. We do, however, have the option of not providing an initial value. This is sometimes useful if you want to have a variable who's initialized by an if statement. Do be warned that if you ever try to read the value of this x without first assigning to it, C++ says anything can happen, not just you might read some random garbage value, your program can crash. Streams are how we handle basic input and output in C++. There are other ways to do input and output, but for now, streams are the default. They give you the same function as print and input would in Python. But cin and cout, our input and output objects, they're not actually functions. They're objects that we use to write to. This operator, this double left angle bracket, you can imagine that it means write to. And when I combine an output and a thing to output, it says write hello to cout. Then write world exclamation mark new line also to cout. Next, I can read input. The arrow's going in the other direction. Hopefully this is at least a little bit making sense. The arrows going the other direction mean read from. So these double angle brackets mean read from cin, put the result into x. I'm going to point out that this is one of the few places where I think C++ can be less verbose than Python. In reading this integer value from the input, I never had to say convert it to an integer like we would in Python. Because C++ knows that I'm reading into a variable of type int, it knows to use the correct input function that does that conversion for me. So when I type this line, it means read essentially a string from the user, convert that string to an integer, and store that integer in x. Similar to Python, bad things will happen if it is not actually an integer. If I type the word hello, this will fail. It will raise an error. In C++, we use the word throw instead of raise, but it's very similar to exceptions in Python if you have learned those. Finally, we can write that out again, and I want to point out this is now one new detail. You can chain these operators together. Technically, and this is a little pedantry again, this operator is left associative. So if I have this operator appearing multiple times, what happens is first we do this step. We write the string you wrote to cout, and the return value of this expression is cout. So we can now stream something else. Now we stream the integer x. And C++ knows, oh, you want to print out an integer. Let me convert that for you. Print in Python does that for you as well. And when we're done doing that, we'll stream one more thing, which is the new line, to finish it off. Strings you can similarly use as a basic value type in C++. You do need to include a library because it is not part of the core language, it's part of the standard library. I can read into them with cin, and this will read until the next white space. So if I were to type mint and chocolate chip as several words, this piece of code wouldn't quite work correctly. You can write strings to cout just fine. And I'll also point out that some other basic operations like less than, equals, the comparison equals, all work on strings, mostly as you would expect. Let's talk about functions. Every C++ program has to have at least one function called main. This is a difference from Python. In Python, you can include statements one after another, not inside of any function, and when you run that file, Python will just run those statements in order. In C++, however, every statement should be within a function. And one of those functions is special and is the function that gets called when your program starts. It's a small difference. That special function is main, and for now we'll say that main takes no arguments. There are other options, and returns an integer. This is a little weird. There's a special rule that you don't have to write return 0 in your main. It's optional because, historically speaking, this 0 is used to signify whether your program ran successfully or not. 0 means success, anything else means it failed. And because it's so common to just have your program always return success, you can leave it out. And if you leave it out, your program will automatically say, yes, I was successful. Here we see three functions. One function that takes an integer and returns the next integer. A function that prints a greeting given a name. And notice, remember I said earlier, if your function doesn't return anything, it should be marked as returning void. Finally, we have int main. So the actual program will greet Tim, will greet you, and then return 0 to indicate it succeeded. Notice a few details here. One, the next function is never used. That's okay. The greet function is defined before it is used in main. If I had moved this code below main, further down in the file, which would have been acceptable in Python, the compiler would have gotten to this line and said, you're asking me to use greet, but I don't know what greet means. And it would fail. So for now, we will put our functions in the order they're dependent on. So because main calls greet, we define greet before main. In the next lesson, I will go over how to deal with that a little better. Conditionals, if statements, your most simple flow control. There's only a few small differences here between C++ and Python. We use double ampersand instead of the word and, but it has the same behavior. It's a logical and with a short circuit. If the first part is false, it doesn't even bother with the second. We use a double vertical bar instead of or, and we use an exclamation mark instead of not. Also, we use else if instead of elif. Elif as a word only exists in Python because of how it interacts with spacing. Otherwise, in Python, you could achieve the same thing without elif, but your indentation would keep moving over to the right with each case. Since C++ doesn't care, we don't need a special construct. I'll note that the parentheses, as I said earlier, are now required. And as one more mention, in case you see this in code, these curly brackets are actually optional if your statement is only one line. But I'm going to tell you, don't take advantage of that. it can lead to some very surprising bugs, and you can have some very unfortunate accidents. So please use the curly brackets, pretend that they're required. For your homework, I'd like you to write a simple C++ program that you could imagine is helpful with math homework. It's a bit contrived, and it really only does a few formulas. It's not so powerful that it would actually be worth writing this program, this very specific example, to help with your homework, but it's meant as an example of how we could do something that's starting to be a little useful. You can fail however you want if there are bad inputs. I do want you to be careful about the types. Hopefully that'll be mostly straightforward. Your output should match exactly what I have on the next slide. And when you're done, I want you to commit and push your changes to GitHub. Follow the same instructions as before. Now you will be in a folder HW-0.1 named for this lecture. Hello, who is this? This is what the computer will print out when I run the program. I, as the user, will type my name. It'll greet me. Hello, would you like me to compute for a rectangle, square, rectangle, or circle? I'll pick one of those. I'll type rectangle. At this point, I want your program to call a function called square, rectangle, or circle that will carry out the rest of the steps, because they will be different. And I want you to use functions to kind of label the different sections of code. So now that I've asked for a rectangle, it's going to ask for the length. I'll say 5. It'll ask for the height. I'll say 3.5. And when I'm done, it'll say that the area is 17.5 and the perimeter is 17. So it's going to do the area and perimeter calculations for whatever shape I ask for. Again, when you're done with this, please submit it to GitHub the same way you did before. If you have any questions, please send them to whoever you're in contact with for this class. Thanks, and I'll catch you next time.